Hey Bruno, welcome back to another episode of Bruno's Biologs. It's really a space where I get to explore different aspects of life science, from research breakthroughs to the science that's really shaping our future. And lately, I've really been thinking a lot about transplants. And thankfully, it's not something that I personally have to worry about at this given point in time, but it's really always been a passion of mine ever since I was a kid. I mean, I still remember Christina Yang on Grey's Anatomy is making an absolute fuss over a heart transplant, like her heart depended on it. And fast forward to college, studying hemodynamics in my chemical engineering classes, where I was literally studying about the physics about how blood moves through the human heart. And now, with the more recent news about the first true artificial heart being implanted, it's been on my mind again. If you haven't heard, please let me be the one to explain to you. At St. Vincent's Hospitals in Sydney, Australia, a man received the first ever truly fully artificial heart designed by an Australian engineer, Dr. Daniel Timms. It's called the bivaker, and instead of mimicking every tiny part of the human heart, it actually uses one singular moving piece, a magnetically levitated rotor, to pump blood through the human body. It's clean, it's compact, and it's pretty elegant. The surgery was a huge success. The patient lived over 100 days with the artificial heart before successfully receiving a donor heart transplant. 100 days powered completely by titanium and magnet. It's really a glimpse into a future where, when donor hearts are scarce, we can have these iron replacements just ready to go. And if that wasn't exciting enough, just last month, another major breakthrough caught my eye. Dr. Nick Banovich and his team at TGen and Vanderbilt used my company's Xenium platform with its 477 gene panel to study real human heart transplant biopsies at a single cell level. Think of it like Google Maps, but instead of using streets and buildings, you're actually mapping every single cell inside of a heart biopsy and seeing exactly which genes are turned on. Nick's team looked at patients going through different types of transplant rejections, like acute cellular rejection, antibody-mediated rejection, and they found different immune cells, like T cells, dendritic cells, macrophages, and fibroblasts, didn't just show up randomly. They actually clustered together in distinct patterns depending on the type of rejection. And here's the kicker. They saw that patients with more activated immune cells before treatment actually responded better to anti-rejection therapy. They also found molecular signatures that could potentially predict whether a patient would respond to treatment even before symptoms would show up. So, what do these two stories really have in common? Both the bivaker and Nick Banovich's spatial biology research are giving patients a second chance at life. One story is about engineering a brand new beating heart, and the other is about using cutting-edge molecular maps to better save transplanted hearts. Together, they really show us a future where the science of replacement and preservation can come together. Whether it's a machine or a human organ, we can really better understand, heal, and protect the hearts that keep us alive. And honestly, I think Christina Yang would approve. Thanks for taking the time to tune into this episode of Bruno's Biologs. If you'd like to dive into the future of transplant, make sure to hit a like, subscribe, and let me know what your thoughts on what the next breakthrough in science I should be exploring next. Until then, stay curious.